All right. So if you remember yesterday, we were dealing with this quadratic formula. And if I were able to factor this, so this was the x plus 10, x minus a 2, and then the x values that make this a 0, and the x values that make this a 0, those are what we would call our solutions. That's where we cross the x-axis. So when we factor and find our zeros, those are our solutions, those are our x-intercepts. We can do it with the quadratic formula. We finished this in your class. We went through, we got the exact same answers that we got over here. Okay. Factoring is obviously easier and it's quicker. So if it factors, then the quadratic formula is sort of something we probably would want to avoid because there's more work involved. But if it doesn't factor, so that's then kind of what we're now going to do in number 2. If I'd asked you to try and factor this one, this would keep you busy for a while. So we're not going to go through it all, but if we actually tried to set up that little area model and try to get an x squared or 2x squared to like 2x and an x, and this has to be a 5, there's no way we're going to come up with a area model that factors this. So the answer to this, does it factor, is no. I need a new pen. So that's what you're putting in there. So because of that, if it doesn't factor, for us to find our solutions and our zeros, we would then need a different method. And that's what the quadratic formula allows for us. And so this is a no. And as of right now, we don't know what our solutions are, what our x-intercepts are, because it didn't factor. But if we come over here to the right-hand side of the paper, do the quadratic formula, that should then give us this. Also understand that because this factored, we got these nice numbers, rational numbers, on our quiz. We'll go over the quiz tomorrow, by the way. On our quiz, rational versus irrational, these are rational numbers. When we use the quadratic formula, you're going to get these nice rational numbers. When we can't factor, so notice again, I said this cannot factor, we should be getting irrational numbers here. We'll get ugly numbers with radicals in them. Okay. So first, know what the quadratic formula is. So that was the negative b plus or minus the square root of b squared minus 4 times a times c, and then all over twice a. So then the question was that we talked about yesterday, what's a, what's b, and then what's c. So a is nothing more, if we look at this square term right here, it's the number in front of the x squared. So in this case, it would have to be a 2. If I ask you what the b is, we come over here to the middle term, that x to the first term, whatever number is in front of that, that's got to be our b. And then the final thing, if I want to know what c is the constant hanging out at the end. In this case, it's a positive 5. So as long as we're in standard form, remember this is standard form for a quadratic. We did standard and vertex form. As long as we're in standard form, we can just look at those to get our a, b's, and c's. Okay. From there, then we substitute in. So the first one, I said that b. So let me get the other color up, because what we want is b, and b is a negative 8. However, we want the negative of b, or the opposite of b. So if our b is originally a negative 8, when we substitute that in, it should be a positive 8. It just changes the sign. Plus or minus b squared, so take that negative 8, you're going to square it. And then we do minus a 4 always. And then whatever a is, multiplied by whatever c is. I'm going to unplug some things before I lose my computer here. So a should be 2, and then c should be the 5. And then all divided by 2 times a. A is again 2. All right, write small, because as I look, I see I'm not going to have enough room. So try to control yourselves like I did not. Go ahead and square that 64, or the negative 8. And that, come on, should give us 64. And then now here's where you need to be careful. I'm telling you now, this is where people mess this up. It's just understanding this is a negative 4 times 2. So that's a negative 8. And then that has to get multiplied by a 5. So a negative 8 multiplied by a positive 5 should be a negative 40. So minus 40. All divided by 2a, which is 4. All right, I'm going to try to squeeze one more line in here. So you then have 8 plus or minus the square root of 24, all divided by 4. All right, and then do that. Then what we need to do is that 24 needs to get simplified a little bit. So think about the numbers that multiply to be 24, but would be a perfect square. One of them is a nice perfect square. My guess is the first two that you think of. Most people would probably go right to the 4 and the 6. And we would get 8 plus or minus the square root of 4 is 2, root 6, all divided by a 4. So if you give me this answer, that is totally fine. So when it comes to a quiz or a test, if it's one where I want you to show work and I want to see what your final answer is, if you give me this answer, this is correct, 100% correct. However, if it's multiple choice, I would definitely reduce this. So we want to make sure we know how to reduce this. So if we now look, notice how the 8, all the terms that are not radicals, notice how they're all divisible by 2. So what we want to redo is reduce all of those by 2. So the 8 is going to become a 4, the 2 is going to become a 1, and this 4 down here is going to become a 2. So the reduced version is 4 plus or minus root 6, all divided by 2. If you don't want to reduce, come quiz test time, you don't necessarily need to. I would take that first version. This is 2 answers. We don't have to do this here. We don't have to actually set up the 2 different equations, but what that now gives us, and again, remember what I just mentioned, since this did not factor, we were going to get some ugly numbers, and that's what we just did. But these are now our x-intercepts. So 4 plus or minus root 6 divided by 2 are both our x-intercepts and what we would call the solutions to that equation. Is where we cross the x-axis. All right, Sally. This got recorded too, Sally, so you'll catch up on anything you missed.
So, Mr. Green, if we didn't simplify it, would the x-intercept be?
Yep.
8? Okay.
This is totally fine when it's you doing the work. If you leave it unsimplified, I wouldn't mark off for that. Okay.
Okay, and then that would be the answer to the x-intercept as well.
Correct. The x-intercepts and solutions mean the exact same thing. Okay. All right. So let's try to get through one more here. I want to see if we know what we're doing. So for this one here, one of the things we could do is solve this using the quadratic formula. All right. In fact, let's just do this. We're not going to do this one anyway, so cross that one out. And what we're going to do is over here, we're going to solve it by completing the square. And then on the other side of the paper, we're going to solve it by doing the quadratic formula. So let's split the paper up that way for this problem. We should get the exact same answers. All right, either way. So completing the square. Completing the square is when we took these first 2 terms, the x squared plus a 10x. We did this a little bit yesterday as a review. And we made a perfect square out of those 2. And then we adjust the negative 1 at the end. All right. And then now it's just an equation set equal to 0. So what we did, I would have had to have taken the 10x's. I would have put 5x's here, 5x's there. So I have a 5 and a 5. Those multiplied together give us a 25. So that's how we make that a perfect square. And because I add 25 there, let me do this real quick. We had to subtract 25 from that negative 1. So if we now do this, we had x minus 5 on top. We had x minus 5 or x plus 5, sorry. So we're going to write this as x plus 5 times x plus 5, or just squared, minus 26 equals 0. So we're now putting 2 different ideas together. This is what we would have done in the last chapter, module 2. What we now just quizzed on is solve this equation. So the way we solve this equation in that last quiz, I would have told you to get this guy by itself, get it isolated. So for us to do that, we would now want to add the 26 to the other side, so that we get x plus a5 squared equals 26. Once we had done that, you should have taken a square root of both sides. So square root it. Take a square root of the 26, knowing that we get that plus and minus solution, the positive and a negative solution. We just have x plus 5 by itself on the left. And then on the right, we get a positive and a negative root 26. From there, we've got to subtract our 5 over. So minus 5 minus 5. And then remember, we just wrote this as x plus or minus root 26. Actually, let's do it this way. I think I had you do two different equations here. No, let's go ahead and write it. We can't put those together, so we just wrote it as plus or minus root 26 minus a 5. And then I would have you write two different equations often. I would say do the root 26 minus a 5, and then do the negative root 26 minus a 5. Those are our two solutions to this equation. All right, so that's what we quizzed on last Monday. And I'm going to open that up for you tomorrow. We'll look at it tomorrow. So this is one way we can solve this equation. So we can factor if we can factor. We can complete a square, use the square root stuff like we just did, or we should also be able to do the quadratic formula. We better get these exact same answers. Okay, so now let's test it and see if we do come up with the exact same answers. So first thing, identify what is your A, what is your B, what is your C. So write A, B, and then C. Make sure we have that part down. All right, A is the number in front of x squared, so that's a 1. B is the number in front of your x to the first, that's a 10. And then C is the number in front of your 1, or the number by itself, which is a negative 1. And make sure it's a negative 1. It's a minus a 1, so that means that 1 is negative. We then write the quadratic formula, and then we just plug those values in accordingly. All right, so from there, this is something to just be careful of. Whatever B is, right now it's 10. The negative in front of it means we want to change the positive 10 into a negative 10. Plus or minus, do the 10 squared. So B is a 10, so 10 squared, and then minus 4 times A and then C. So A is a positive 1, C is a negative 1, all divided by your denominator, which is 2 times an A. So take a minute, clean up underneath the square root. I want to see how we handle that. This is, again, the place where people mess up the most. So now just do underneath the radical, see what we end up with. All right, go ahead, Cam. What was 10 squared, Cam?
100.
All right, and then what'd you do next?
So you multiply the negative 4 times 1, which is a negative 4.
Good.
And you multiply the negative 4 times the negative 1, which is just positive 4.
Good. So make sure that we have this 100 and make sure this ends up being a positive 4. Okay, good. So then ultimately, completely simplified, we should have plus or a minus the square root of 104, all divided by 2. Remember, what I just got over here So these two answers here, I better get the same exact answers out of this one. Okay? So we're not there yet. This better eventually look like this. They better look the same. So the reason we can be able to go further now is we want to come up with numbers that multiply to be 104, but are also perfect squares. Not an obvious one, but if you know what these answers are, right, isn't one of them going to have to be a root 26? If we know that that's what the answer is going to be. So put that right here, because the 26 is not good. We can't simplify that any further. And if you think what number multiplied by 26 would give me a 104, and it has to be a perfect square, the only legitimate option is a 4. All right, and then I am running out of room, which is not good. So next one, if I can squeeze this in, let me hide that. I get now a negative 10 plus or minus, shoot, let me do it over here. Actually, let me do this. So on yours, if we rewrite it, look at this square root of 4. We know what the square root of 4 is, right? We all agree that's 2. So since I don't have to try and find extra space, I'm going to change the square root of 4 into a regular old 2. Starting to look like this. But then what we talked about earlier, look at these three numbers now, the non-radical terms. Oops. So this guy here, this guy here, and this guy here, do we agree all three of those are divisible by a 2? That means we divide all of those by 2. So this, if I divide that by 2, becomes a negative 5. Plus or minus, if I divide this 2 by 2, I get a 1. So just a 1 root 26. And then isn't my denominator now just a 1 if that 2 becomes a 1? So if we now look at this answer here, don't I have a negative 5 being added to a root 26, just like I do here, positive root 26 and a negative 5. And then the negative 5 minus a root 26 is what I have right here. Okay? So just different ways to kind of go through these and be able to work with it. This one works all the time. So the nice thing about the quadratic formula, it will always work. If you can't factor, this will still work. If completing a square is tricky, this will still work. So the quadratic formula covers everything. All right, it takes care of every issue that we would come across when we are doing this. All right. All right. Let me pull. That's all I wanted for the day. All right, so here's what you're gonna do now. That's basically what I wanted to get through today, but 2 things, so do not go off because you got to do something real quick. So first, homework. Let me pull that up first. In your homework packet, so if you have the packet, you're doing page 17, and you're going to do 1 through 6. All right, so it's just the 6 problems, doing that quadratic formula. All right, going through these guys, making sure that we can do that. All right, so that's for tomorrow. If you don't have the packet printed, then you can get the homework again right here on the notes, where underneath the notes are at. That's the homework. All right, and then make sure you get that uploaded for tomorrow. Okay. I don't know. 1 through 6. Yeah. So yeah. So right there, page 17, 1 through 6 in the packet. All right, and then the last thing that I want to do for the day, you know what? Yeah. No, you know what we're gonna do? I don't leave you too much time for that. Go to the homework. Go to number 5. Let's do this real quick. So your directions here. First, factor that. So give me the factored version of this. So this is in the homework, number 5. So tell me what numbers would work here. Multiply be negative 30, add up to be 7. What do you got, Ahmed?
10, -3.
Good. Positive 10, -3. So if we can factor these are really short and sweet, because now all we're thinking, what makes this a 0? And that would have to be the -10. And then you think, what x value would make that factor a 0? That would make that 3. So those are your solutions. Those are the answers. Now, what we're doing, though, is in the next part, I want you to show that you get the exact same answers using the quadratic formula. And we better get these guys. All right. So when we go to plug these in, let's list our A, B, and our C. A has to be the 1 in front of the square term. C has to be the 7. B has to be the 7, and C has to be that -30. When we plug these in, I want the opposite of B, so I want a -7, because the B was a +7, plus or minus B squared, so 7 squared, and then 4 times A times C. A being a 1, C being a -30. And then all divided by 2 times A. Again, we better get -10 and 3 as our answer, so if we don't get that, we know we screwed up somewhere. So as we go through this, 7 squared is 49. Here's where you want to be careful. The -4 multiplied by that 1 would give you a -4 initially. That -4 then gets multiplied by a -30. So a -4 and a -30 should make a positive 120. All divided by 2. Add those up, be 169 divided by 2. Maybe not one that you know, but again, if it factors, that means I better get a perfect square right here. This has to be a perfect square. If I factor this to get nice numbers, that means I should get a nice number here. The square root of 169 is a 13. So the way we're now going to get a -10 and 3, this is where we set up our two equations. I'm going to take a -7 and I'm going to add 13 and divide that by 2. All we're doing, we're using these two signs to create our two different equations. The other one, I do a -7, I subtract 13 and divide by 2. So the first one, notice how I get 6/2. That's the 3 that I knew I was supposed to get. And then the other one, when I subtracted 13, that's a -20 divided by 2. That gives me the -10 that I'm supposed to get. It's like magic, okay? Like a magic trick. We just got the exact same answers. We just do it a couple of different ways. All right. If you wanted to complete the square, if you were really anxious, we could complete the square here, use the square root stuff that we just quizzed on. You're going to get, again, the exact same answer. All right. So just a bunch of different ways to skin a cat, as the old expression goes. All right. So you're going to do 1 through 6. You've already got number 5 done, so that you don't have to do anything else with. But what I do want to do, I kind of like the little exit quiz that I gave last week. It lets me know if we understood at least the basics of what needed to go on. So what I want you to do here in the last 10 minutes, and this should literally take you about 3 minutes when I turn it over to you here, is take this little exit quiz for me, show me that you at least know the basic stuff that we've been doing here the last 2 days. Oops. So this is you guys. So open up another tab. I gave you 10 minutes. It should not take 10 minutes. When you are done with that, you are free to go. Make sure first period, yeah. And go ahead and do that for me, okay? So when you're done, you can check out. We will see you guys all tomorrow. And then just remember, you got those problems for homework due tomorrow night, okay?
Mr. Pena,
Yes, Ahmed.
says it was expired yesterday at 10:30.
Yeah, I got the same thing.
You did? That shouldn't have happened. Mastery Manager made all these new changes to me literally overnight. So let me make sure. It's like a whole new window now, Mr. Kubowitz. You're not gonna like it. Come on.
Yeah, I just clicked on it and it's completely different.
Yeah, right?
And I just figured out how to work the other one.
Yeah, I don't know why they feel the need to do that.